learners chemistry, and welcome to some ionic naming practice. So for starters, let's go ahead and summarize what we talked about previously, right? So we said that when we're doing our naming, right, step one is that we need to identify if it is type 1 or type 2, right? Type 1 or type 2, where type 1 is invariant charge, right? Type 2 is variable charge. And then we need to, within each of those respective types, right, determine if it is binary, right, or contains a polyatomic ion, right? Because that's going to change how the ending of the name goes, right? So type 1 or type 2, it is a binary or a polyatomic ion, okay? And that's what we're going to use to guide us as we write our formulas. So, all right, so we have calcium, which is a metal stuck to a non-metal, so definitely ionic, right? Is it type 1 or type 2? All right, type 1, because calcium, right here, is definitely one of our group 1s, right? Is it binary or polyatomic? Right, it's binary. Okay, so now, so we're just going to write its whole first cation, which is calcium. We're going to use the root of the second one, and we're going to end it with "ide." Yes, calcium oxide. Next up, we have this one. So we have a metal stuck to a, right, polyatomic ion. Where does that metal come from? Right, this is a type 1 because magnesium comes from group 2. Is it binary or polyatomic? All right, it is a polyatomic, which means we'll use the full name of that polyatomic ion when we get there. So this one is magnesium, and then we're going to just end it. Here we don't change endings, right? This is NO3 is called nitrate, so nitrate is what we end the compound with, all right? Next up, we have another compound. So copper, is that a metal? Yes, right? Sulfate is a polyatomic ion, so we know it's a poly, right? Type 1 or type 2? Right, this one is a type 2, which means that what special thing has to happen? Right, we've got to work backwards to figure out its charge. So let's go ahead and get the other pieces of its name, right? So we know it's going to go with the full name of the cation, and because it is polyatomic, we're just going to use the full name of that anion. Next, we have to come up with the charge. So if we think about what we talked about in the previous video, where the goal is that the amount of positive charge has to cancel the amount of negative charge, all we're doing now is working backwards, right? So I know that I have one copper sulfate with a charge of, one sulfate with a charge of -2, right? I have one copper. What kind of charge must it be? Right, it must be +2. Yes, copper 2 sulfate. All right, next up, we have metal, non-metal, so definitely ionic. This is one of those special type 1s you just have to memorize, right? It is binary because it's only composed of 2 elements. So this is going to be silver, chlor, root, ends with "ide." Yes? All right, next up, we have some tin stuck to another polyatomic ion. Tin, if you take a look at your periodic table, right, type 2, this is a polyatomic ion, right? So tin, charge, full name of that polyatomic ion, which is hydroxide. And then we're going to have to work backwards again, right? So we have 4 hydroxides with a charge of -1 each. We have 1 tin, right? So that tin's charge must be, right, +4. All right, next up, we've got sodium and we've got this polyatomic ion, right? So type 1, because sodium comes from group 1 with an invariant charge. We've got HCO3, which is a polyatomic ion, right? So this is going to be sodium, and the name of that is bicarbonate. You could just as well call it sodium hydrogen carbonate, and that would be fine also. All right, next up, we've got copper stuck to this, right? Copper chlorite. So, well, I didn't mean to say that. All right, so it's a type 2 because copper comes from the middle section of the table, right? This is a polyatomic ion, right? So copper, charge, right? And here is where knowing our elements, our polyatomic ions, is important because we would just recognize ClO2 as being chlorite. Now we have to work backwards, right? I have 1 chlorite with a charge of -1, I have 1 copper, which means that the charge of copper in this case must be 1. Yes? Make sense? All right, now let's do some of this other naming on the other side, going the opposite direction. So potassium permanganate. So this really is just like we did the other day, where all we're doing is writing the formula based on what it's made of, right? So potassium permanganate. So here's where we need to recognize, oh, permanganate is polyatomic ion. Potassium is this with its positive charge. So again, just like we talked about in 5.6, right? We come up with the formulas and we come up with their respective charges, right? And then we need to make the amount of positive equal the amount of negative. So the formula is KMnO4, 1 of each, okay? Lead 4 phosphate. So lead is Pb, right, with a charge of, right. For all of your type 2s, these are actually easier, right? Because I'm telling you lead 4 phosphate, which is PO4, 3 minus, right? What is the lowest common multiple between 4 and 3? Right, 12, which means I need 3 of these and I need 4 of these. So I'm going to say PB3, PO4, 4. Yes? All right, next up, we have some sodium perchlorate, right? So sodium is Na+, perchlorate is ClO4 minus, right? That one's easy, 1 of each. Lithium is plus bromide here. Ide means it comes from, right, bromine as an ion, right? So LiBr, right? Lithium bromate. And you might be like, oh, lithium bromate. What is that? What am I supposed to do here? Well, here is where understanding our naming system means actually that table of polyatomic ions is only a small subsection of what you really know, right? Bromate. Let's follow our naming conventions, right? So bromine is in the same column as, or the same group as chlorine, right? So if I know that chlorate is ClO3, right? ClO3 minus, then if I wanted to talk about bromate, which is in the same group, I know that by extension it's going to behave similarly, right? Like if chlorine is capable of bonding to 3 oxygens and forming a polyatomic ion with a charge of -1, right? Bromine is likely to behave similarly because they're in the same group, going back to group properties, right? So BrO3 minus, so LiBrO3, okay? Next up, we have some ammonium, and you might be like, ooh, ammonium, and then you might scour your periodic table, but then you'd be like, oh, that's right, that's one of those ones I memorized, right? NH4 plus, dichromate, and so some of them just have kind of weird names, right? So Cr2O7, so you just have to have things memorized well enough that you don't get confused by them. So clearly the lowest common multiple is 2, so I'm going to need 2 of those, I'm going to need 2 ammoniums for one of those dichromates. Next up we have vanadium 3, so that 3 again is the charge of that, so V, 3 plus. Iodide, ide is your big clue, we're talking about iodine as an ion, right? So then I need 1 of these and 3 of these, so VI3. Yes? All right. We are going to do lots of practice. Thank you for listening, be good, and I will see you soon. Bye.